So, so in this video, let's start with web application threads module, and we will cover the first thread of OSP, that is the top one thread, which is injection. So injection flaws such as SQL, command injection, LDP injection, etc. occur when untrusted data is sent to an interpreter as part of a command or query. The attacker's hostile data can trick the interpreter into executing unintended commands or accessing data without proper authorization. There are many types of injection flaws, some of which are discussed below. Note, whenever I hear about injection attack, first thing that comes to my mind is injecting via forms. But keep in mind that there are many other attack surfaces that we can inject malicious payloads, like in cookies, in PHP parameters, anything that can be passed to a web application. And if that input supplied by the user is executed in some form by maybe Python exec statement sent directly to bash terminal, PowerShell, etc., could lead to users executing arbitrary commands. So SQL injection is the most common website vulnerability on the internet, and it is used to take advantage of non-validated input vulnerabilities to pass SQL commands through a web application for execution by a backend database. In this technique, the attackers inject malicious SQL queries into the user input form, either to gain unauthorized access to a database or to retrieve information directly from the database or to edit the contents of the database. So there is a dedicated module for this. So we can see when discussing about that module. So after SQL injection, let's see command injection. Attackers identify an input validation flaw in an application and exploit the vulnerability by injecting a malicious command in the application to execute supplied arbitrary commands on the host operating system. Thus, such flaws are extremely dangerous. The following are some types of injection attacks. Example, a website to ping. The attacker can give a ping 10.10.10.10 semicolon cat slash etc slash password. Okay, then the next injection after SQL injection and command injection is shell injection. An attacker tries to craft an input string to gain shell access to a web server. Shell injection functions include system, start process, java.lang.runtime.exec, system.diagnostics.process.start, and similar APIs. HTML embedding. This type of attack is used to deface websites virtually. Using this attack, an attacker adds extra HTML based content to vulnerable web application. In an HTML embedding attack, the user input to a web script is placed into the output HTML without being checked for HTML code or scripting. Next is file injection. File injection. The attacker exploits this vulnerability and injects malicious code into system files. Example, certifiedhacker.com slash vulnerable php color is equal to http slash slash evil slash exploit. It occurs when a user is allowed to supply input for the include command dynamically, which is not properly validated before processing. When a user provides input, the web application passes it into file include commands. Most web application frameworks support file inclusion, hence an attacker enters a URL that redirects the application to the location of malicious file. Example, you can see here there is a very simple HTML form where we can select a drink, either Pepsi or Coke, and there is a input type submit. So this is how the page looks. So when a user selects a drink and submits the below PHP code will be executed. As you can see, the PHP. Um, by default, the drink is initialized to Coke, and the script is extracting the value of drink. And if the drink is set, then then it is assigned to a variable called drink, and then using this require by calling this require function, uh, the variable drink is appended to .php. That means if the value, if a parameter or value selected is Pepsi, then the require function's parameter will be pepsi.php will be called. That means the script pepsi.php will be executed. So the attacker can intercept and run another malicious file in place of this pepsi.php. Here, dollar underscore get is a PHP super global variable which is used to collect form data after submitting an HTML form with method equal to get. The include or require statement takes all the text code markup that exists in the specified file and copies it into the file that uses the include statement. To exploit the vulnerable PHP code, the attacker injects a remote host file at www.jasoneval.com which contains an exploit. Exploit code looks like this. Next is LDAP injection. So LDAP injection is an attack method in which websites that construct LDAP statements from a user supplied input are exploited for launching attacks. When an application fails to sanitize the user input, the attacker modifies the LDAP statement with the help of a local proxy. This in turn results in the execution of arbitrary commands such as granting access to unauthorized queries and altering the content inside the LDAP tree. Depending on the implementation of the target, attackers use LDAP injection to achieve login bypass, information disclosure, privilege escalation, and information alteration. To test if an application is vulnerable to LDAP code injection, send a query to the server that generates an invalid input. If the LDAP server returns an error, it can be exploited with the code injection techniques. As you can see, the following is an in that figure. It's an example of LDAP injection. So in the username field, the attacker has entered certified hacker closing parenthesis, open parenthesis, and again closing parenthesis. Password can be anything. So here, if an attacker enters a valid username and injects the above said payload, then the URL string becomes like this. So and user is equal to certified hacker and pass is equal to blah. The LDAP server processes only the first filter. Only the query and user is processed. This query is always true and the attacker logs into the system without a valid password. Other injection attacks, server side JS injection. Server side JavaScript injections are vulnerabilities that manifest when an application integrates user controllable values like an input to a form. So this user controllable values are converted into a string that the code interpreter dynamically validates. So an attacker exploits improper validation of user data and pass random values to alter the code that will be compiled and executed by the server. Example 1, an attacker can launch a DOS attack by passing command by using eval function. So the parameter passed to eval function may be while1. So which creates an infinite loop and thus a DOS attack. So to avoid, so one of the mitigation is to avoid eval function. Another example, as you can see in this diagram, an attacker has entered uh, code code uh, code code res.end, and the parameter passed is test cybers. So here we are injecting the JavaScript in the form of res.end test cyber. So another example is res.end require, the parameter passed to require is fs, and then dot read dir sync, parameter pass is dot, that is current directory, dot represents current directory, and that is converted to string. So this lists the current directory. So the parameter passed to require fs means file system. So and then here res.end means end the response. So but before ending the response, it executes whatever is passed to res end. So here we are passing the dot, that is list the current directory command. So it will list the current directory command. So require fs means include file system. Read dir sync dot means read current directory, and then to string is to convert the output of read sync to a string. Similarly, we can also list the parent directory using dot dot by passing a dot dot as a parameter to read dir sync. So next is server side inclusion injection, SSI. So what is SSI? It is a server side scripting language that is used on the web like JS. Its extension will be SHTML, SHTML or STM or SHTM. Server side include SSI. SSI is used to perform some actions before the current page is loaded or while the page is being visualized. It is most useful for including the contents of one or more files into a web page on a web server using its hash include directive. So on any web page, if you want to include some content of a file or some other web page, then this hash include directive can be used. So SSI has a simple syntax, as you can see here, within the less than greater than symbol, we can use this hash directive, hash include a parameter, and we can give the script directive. These directives are placed in the HTML comments. Few examples of directives are shown here. Include exec executes a program, script or shell command on the server. Echo, this directive displays the content of a specified environment variable. Variables include HTTP user agent, last modified, and HTTP accept. So the example, a web page containing a daily quotation could include the quotation by placing the following code into the web page. Hash include virtual is equal to dot dot slash code dot text. So the example of an attack is here. Instead of hash include, the attacker can replace hash exec, and the command can be cat slash etc slash password. So the countermeasures validate user input and ensure it does not include SSI directives. Apply HTML encoding to the user input before execution. HTML encoding makes sure that the text is displayed correctly in the browser and not interpreted by the browser as a HTML code. So, if you encode the HTML, it will be treated as a text, not as a command. So it's better to encode. So ensure directives are confined only to web pages where they are required. Avoid using pages with file name extensions such as .stm, .shtm, and .shtml. Next is server-side template injection. Templates are used. For example, when a new user register to some website, you will get a welcome email saying hello user welcome and some other message. Here user is a dynamic, and the same kind of email will be sent to every new user using a template. In the template, user is dynamic field. The attacker has to do something with the only user only, and all other things are fixed. So the attacker has to target the dynamic field in this template. So this injection is similar to cross-site scripting, but is often employed to target server internals and achieve remote code execution, making every vulnerable applications a primary target. Template injection manifests via designers' code errors and deliberate template disclosure while showcasing rich features of applications, blocks, etc. Example code below here, the shown here is, it is using a template called Jinja template engine. First step for any attacker to find is to identify what is the template engine that is used by the website. So other examples are shown here. You can refer this diagram. So the example given in Aspen book is this one. So this is HTML code. The templates are used by the double square brackets, the double braces. So this is a template. This is a template. This is another template. So this is how the page looks. So the above HTML code can also be implemented using the template engines as follows. So the template engine is called new template engine. So template is equal to engine load file, sign up TPL, assign title login, assign method post, assign action sign up, assign username, get username from cookie, assign time micro time true, then show. The above mentioned code is vulnerable to template injection as it can execute native functions as in micro time. So if attackers are able to attach template files with such expressions, they can run any arbitrary function to gain access to the target web server. Log injection. Attackers launch log injection attacks by exploiting unsanitized or unvalidated inputs to application logs. Attackers use this technique to insert misleading information in the log file for covering their tracks in the event of a successful attack. So, for instance, consider an application that logs data in the following format: date, comma, time, comma, username, comma, ID, comma, source IP, comma, request. The unvalidated input parameters come directly from the request. So, from this cookie, ID is coming. So, attackers can manipulate the ID parameter to save the log with fake inputs. So that you can manipulate the ID as shown here, slash r slash n fake input. If the log fails to escape null bytes, the remainder of the string is not recorded. So the individual log entry can be prevented at the ID field. Countermeasure: pass log codes instead of messages through parameters. Use correct error codes and easily recognizable error messages. Avoid using API calls to log actions due to their visibility in browser network calls. Pass user IDs are publicly non-identifiable inputs as the parameters at logging endpoints. Next is XML injection. So as you can see, to the user form, XML injection XML code is directly injected to the first name field. So here H1, the header one called honey is typed into the filed first name field, and the vulnerable website is accepting and displaying the header honey. And in this figure, the user query can be manipulated as shown here. So it is referring to an external website, malicious website. So if the user clicks on this malicious link, he will be attacked. So countermeasures for HTML injection: validate all user inputs to remove HTML syntax substrings from user supplied text. So in the user supplied text, that is the values that is submitted in the form field should be checked for the HTML syntax, and similarly check the inputs for unwanted script or HTML code, such as this script keyword or HTML keyword. Employ security solutions that avoid false positives and detect possible injections. Next is CRLF injection. In a carriage return line feed injection attack, the attackers inject carriage return slash r and line feed slash n characters into the user input to trick the web server, web application, or user into believing that the current object is terminated and a new object has been initiated. Suppose that the admin panel has a log file with IP, time, and URL path of the visited site as follows. If an attacker can embed CRLF characters into the HTTP request, she can change the output flow and can enter fake log entries. Furthermore, the attacker can alter web application response as follows. As you can see, carriage return characters, percentage 0D and percentage 0A is inserted at the end of the URL, and then some malicious payload is added here. So, so after injecting the CRLF characters, the log entries will look like this. So there will be two lines instead of one line, the log entry, which will be misleading. So this is about the first top one OWASP application threat, that is injection. So in the next video, we will see other OWASP threats.